Hello, welcome to the tutorial on deterministic finite automata. The objectives of the tutorial is to understand the basic concept of finite automata and to construct a DFA for accepting specific set of strings on the given alphabet. Let's start with the automata. Finite automata is one of the important topics in theoretical computer science. The term automata itself is derived from a Greek word automata, which means self-acting. Here we are talking about abstract self-propelled computing device which follows a predetermined sequence of operations for each specified supplied input sequence. Automata which is having finite number of states or the automata which is defined by the finite number of elements is referred as a finite automata or finite state machines. Let's see the various components or the elements of finite automata when it comes to defining the automata in terms of mathematical model. An automata can be represented as a 5-tuple Q, summation, delta, Q0 and F, where capital Q is a finite set of states available in finite automata. Summation is a finite set of input alphabet, input symbols to be applied to the automata. Delta is a transition function which maps one of the states from capital Q on the application of one of the input from summation gives rise to capital Q, one of the element from capital Q, which means Q from summation gives capital Q. This is the mapping available with delta. Q0 is the initial state from where any input is processed. That means whenever we apply input to finite automata, it's a Q0 from where we start with. Capital F is a finite set of final states for finite automata. It is a subset of capital Q. F is called as subset of capital Q. The block diagram of finite automata is given here. It has input tape on which input is supplied, input is given, so input sequence is given. Initially this tape here points to the leftmost symbol available in the input and there exists one finite control which controls the movement of tape head. Let's talk about deterministic finite automata. In deterministic finite automata, for each input symbol, we can determine the state to which machine will move. There exists another finite automata which is referred as a non-deterministic finite automata. The difference between deterministic finite automata and non-deterministic finite automata is that in DFA, if we apply any input on any given state, we are able to determine where machine will move. Whereas in case of non-deterministic finite automata, there can be either no move or one move or more than one move also on any given specific input from any state. So this is the basic difference between non-deterministic finite automata and deterministic finite automata. Let's see the construction of a DFA for one language. Say construct a DFA for accepting all the strings over an alphabet ending with AB. Now what does it mean? That the strings will be from alphabet A, B. When we are talking about positive, this sign, it's a positive closure, which means that the string derived out of this alphabet will have minimum one length and we can have more than one length of string. That means we will not have any string with a zero length here. Sample set is given here. Say, let's say capital S is the set of states, set of the strings from this given description. We can have different strings like AB. Here we are assuming that this AB is preceded with nothing. In other words, epsilon. Here we have single A followed by AB, single B followed by AB, and so on. So basically every string which ends with AB must be accepted by this DFA which we are going to construct. So if we see here the total set of strings, we can find that AB is the string with smallest length here. So let's start with AB. That means first of all we will construct a DFA which will accept this AB and then we'll try to map it to the different inputs in such a way that from every state of a FA we are able to show where machine will move on the input of A or B or both. So let's start with Q0, which is an initial state. On the input of B, for say, here what we are expecting is the string must end with AB. That is what we are talking about. So if a string is having two lengths only, we will have input A followed by B as shown here. What if we are having B available as a first input? So if we have B available as a first input as shown here, this B may have A followed by B thereafter. Or else say if we are having more than one B, in that case we may have a situation like this, B followed by AB. So what does it mean? That even if we have one B or many number of B's, we can still continue with Q0. Here we will assume that Q0 is the state from where we are searching for A followed by B. So on the input of B, we will be at Q0 only. On the input of A, now let's talk about this scenario, A followed by B. So on the input of A, we must go to a state from where on the input of B, we can move to a state which can accept the given input as shown here. Like A followed by B, we are reaching to a state which we are describing as a final state. Please note that double circle is the notation which we are using here for representing a final state, whereas a state with a pointer, initial pointer, is a initial state here. So we are shown here for A followed by B, the machine is moving to QF, that is final state. Let's consider another case like A followed by AB. What will happen in this case? If we have first A followed by B, then it is this. But if we have multiple A's followed by B, still it is satisfying the criteria of ending with AB like this, A followed by B. So for this first A, we are having this transition. For second A, we have this, and for B, we have QF. So this can justify the third case as well. Like A is this. For this A and A, we will repeat this loop on Q1, like A and A followed by this last B. What about the other options? Like here we have seen for Q0, on the input of A we have shown where machine will move, on the input of B we have shown where machine will move. Similarly on Q1 we have shown for A as well as B, both. What if on QF, that means after encountering A followed by B, we have either A or B? What will do in that case? The case may be A followed by B followed by A, or A followed by B followed by B. So if we have A followed by B and again B, it means that we still need to search for last two symbols as a AB. So we need to make the transition to a place from where we are searching for A and B, and such a state is Q0. So from QF, on the input of B, we are moving transition to Q0. Similarly, on the another input, like A on QF, we need to move to the place where we are coming by A, because this A may be succeeded by another B, which will lead to acceptance of input. So we are going to a state where on the occurrence of first A, we are coming from Q0. Such a state is Q1. So from QF, on the input of A, we are moving to Q1, and from Q1 again we can proceed with the same description as we have explained earlier. Like this case can be shown as A followed by B followed by A followed by B, like the scenario which is available here, A followed by B. So on this A we are moving to Q1, on this B we are moving to QF, on this A again we are moving to Q1, on this B we are moving to QF. So at the end of A, B, we are still at QF, which means this input is accepted. Please note that here for every state, on every input shown in alphabet, we have shown a transition. So we can say that this is our complete DFA. Let's try to represent it in terms of notation form. Capital Q consists of Q0, Q1 and QF as a three state. This is a finite set of states. Summation, here we are using only two symbols, A and B. So summation is shown as alphabet, input alphabet, summation is given as A comma B. Finite set of input symbols. Delta is a transition function with mapping Q cross summation gives Q, which is given by this transition diagram or represented by this transition diagram. Q0 is the initial state as shown here by pointer, and capital F is a finite set of final state. If we see this diagram, only QF is the final state. So we can say that capital F is having just one element, which is QF. We are referring it as a finite set of final states because we may have more than one final state in case of in any DFA. Let's try to see another example. A DFA, construct DFA for accepting all strings over alphabet A comma B. We are using the same alphabet again here, having substring AB. Now what does it mean? That your string may start with A, may start with B, and again it may end with A or B, but it must have a substring A comma B. So basically here we are searching for a sequence A followed by B. Once we get a sequence of A followed by B, we can say that the given string has the substring AB and we can then move to final state. Let's construct again. Start with Q0. On the input of B, move around Q0 only because we are looking for A followed by B here as a substring. So this is A followed by, again same case, B. A followed by B, we are moving to QF. If we are having A followed by A, it means that yet we yet to satisfy the substring criteria of AB. So A followed by B here we have, and if we have anything after we are encountered with one A followed by one B, we can be at QF only because our criteria of having substring AB is already satisfied here. So we do not have to move to any other state. Rather we can show the transition, self transition to QF, a final state, on both the inputs A and B. Again, tuple definition. It will be similar to the last DFA which we have seen. Q0, Q1, QF has a capital Q contents. Summation is the A comma B. Delta is a transition function with mapping Q cross summation gives Q, and Q0 is the initial state. Last but not least, F is equals to QF, which is again having one final state only. In our next tutorial, we will go for many such cases wherein we may have more than one state. We will try to see regular expression, how it is related with the finite automata, how to construct a regular expression for a finite automata, and vice versa. I hope that the objectives which we have mentioned for this tutorial have been accomplished. In case of any queries, kindly give your comments on my video. I will try to solve those queries. Thank you.